If you were to cut a snowflake in half, or maybe look really closely at a honeycomb or even zoom way, way out and map the rotation of a spiral galaxy, you'd expect to see this incredible, perfect geometry.
Oh, absolutely. We are, highly accustomed to finding beautiful fractals and symmetry out in the natural world.
Right, but if you take a second to picture the heart beating inside your chest right now, you probably just picture, well, fleshy plumbing.
Yeah, a mechanical squeeze pump pushing liquid through tubes.
Exactly. A biological engine block that just forcefully squishes blood around to keep you alive. Welcome to today's deep dive into the topic of the spiral heart, cardiac geometry, and electromagnetic coherence.
I am really excited to dig into this one. We have definitely been taught to view the heart as a very linear utilitarian organ.
We really have. Today, we are digging into a fascinating stack of research to challenge that exact idea. We're pulling from a detailed document analyzing human heart valves through the lens of something called the Triaural principle, along with this really in-depth conceptual AI interview that explores the physics of three-pronged tuning forks.
It's a lot to wrap our heads around, but it is fascinating.
It really is. So our mission for this deep dive is to look at the data and figure out a central question. Is your heart merely a mechanical squeeze pump? Or is it actually an intricately tuned resonator that generates the most powerful energetic field in your entire body?
Going from seeing a pump to seeing an intricately tuned instrument is a massive paradigm shift.
Oh, for sure.
But to even approach the energetic outputs of the heart, we have to start by completely reevaluating its literal physical machinery. Because, as the sources show, the anatomy operates entirely differently than standard plumbing.
Okay, so let's dive right in. That brings us to the valves. Let's look at the actual flaps of tissue regulating the blood.
Right, the gatekeepers.
Yeah, the human heart has 4 valves, but the layout is highly specific. 3 of these valves are what the medical community calls tricuspid, meaning they have 3 cusps, 3 flaps.
And that includes the tricuspid valve itself, the aortic valve, and the pulmonary valve.
Exactly.
And what's wild is that when these 3 cusp valves open, their flaps don't just fold back randomly. They form roughly 120-degree angles relative to one another.
Which is such a specific number.
It really is. If you were to freeze frame an open aortic valve and look at it from above, the edges of the flaps create the shape of a nearly perfect equilateral triangle.
And fluid dynamics dictates that pushing liquid through a triangle fundamentally changes how that liquid behaves.
Right.
Like we said earlier, if you squish a water balloon, the water just bursts out chaotically in whatever linear direction it can.
Just raw, disorganized force.
Yeah. But because of this 120-degree geometry, these 3 valves act more like specialized nozzles.
They create what fluid dynamicists call a vortex ring. So rather than a straight laminar stream of liquid, the blood is actually sent into a spiraling toroidal flow.
Like a smoke ring.
Exactly like a smoke ring or a donut. The blood is actually spinning as it moves forward through the vessels. It's a vortex.
And the muscle of the heart itself is completely designed around this spin. The sources detail something called the myocardial band theory.
Oh, right. This was pioneered back in the 1970s by Dr. Francisco Torrent-Guasp.
Yeah, Torrent-Guasp. For the longest time, anatomical science just assumed the heart muscle, the myocardium, was just a thick, hollow blob of tissue that contracted all at once.
Just a simple squeeze.
Right, but Torrent-Guasp's research completely upended that. He demonstrated that the heart muscle is actually a single, continuous spiral band.
Which is so hard to picture at first.
It is. But if you were to carefully dissect and unravel a human heart, it doesn't break into neat little upper and lower boxes. It forms one long, twisted loop, almost like a figure 8.
Which perfectly complements the fluid vortex created by the valves.
Yeah.
You have a spiraling muscle pushing fluid through triangular nozzles.
That's incredible synergy. But if you're sitting there tracking the anatomy, you might realize we have a missing piece here.
Right, we said 3 of the 4 valves have 3 flaps.
Yeah, so what is the 4th valve doing?
The 4th is the mitral valve, and it is bicuspid, meaning it only has 2 cusps.
Which feels like an odd man out. In this highly dynamic 120-degree 3-part system, having a 2-part outlier just seems, I don't know, counterintuitive.
It does.
My immediate thought was that it sounds like an evolutionary design flaw. Like if 3 flaps create the perfect spin, why introduce a dual flap valve into the mix?
Well, in the triaural interpretation we are analyzing today, that 2-cusp mitral valve actually acts as a linear stabilizing frame.
A stabilizing frame.
Yeah. Symbolically, it represents duality and balance, but functionally, it acts as an anchor. It ensures a strict one-way flow of blood from the left atrium to the ventricle without any backflow.
So keeping things in check.
Exactly. It provides the rigid stability required so the other three triadic valves can generate their massive vortexes.
I was trying to visualize this, and I like to imagine trying to wring out a heavy soaking wet towel.
Oh, that's a great analogy.
If you just press your hands together on the towel, like a standard two-part back and forth pump, you only squeeze out a fraction of the water. It's incredibly inefficient.
Right, you're just flattening it.
Exactly. But if you clamp one end of the towel perfectly still and apply a twisting spiral motion to the other end, the water spirals out with concentrated directional force.
That's a perfect way to describe it.
So the two-cusp mitral valve is basically the stable hand holding the top of the towel, while the three tricuspid valves and the spiral muscle do all the twisting.
That mechanical relationship is absolutely vital. And a really fascinating evolutionary detail here is that this specific trio of three cusp valves is a hallmark of mammals and birds.
Creatures with four-chambered hearts.
Yeah.
And those are the animal groups widely considered by biologists to be emotionally and socially complex.
Yeah.
Like fish and amphibians don't have this intricate 120-degree tricuspid geometry.
Which really suggests that this structural complexity evolved in tandem with higher-order nervous systems and deeper emotional capacity.
That makes perfect sense when you factor in some of the wilder physiological traits of the heart.
Like what?
Well, for instance, in a developing human embryo, the heart starts beating and pumping before the brain is even fully formed.
Oh, wow. Yeah, that is a huge point.
The sources also highlight research from Dr. J. Andrew Armour. He actually coined the term heart brain. He discovered the human heart literally contains around 40,000 of its own sensory neurites, or basically neurons.
40,000 neurons right there in the tissue.
Yeah.
So the heart has its own intrinsic nervous system. It can learn, remember, and make functional decisions entirely independent of the cerebral cortex in your head.
It's literally a second brain. So we have this twisting, spiraling, semi-independent brain muscle pushing conductive fluid through three triangular valves, all regulated by a dual flap anchor.
When you lay it all out like that, it sounds like science fiction.
It really does. But in physics, you can't have a moving, spiraling vortex of conductive fluid like blood without generating something else entirely.
Right. Moving charge creates a magnetic field.
Which leads us directly into the energetic outputs. Flowing fluids and twisting muscles generate an energetic signature.
And when you combine three 120-degree vortexes in a single organ, you get what the sources refer to as the master toroid.
A master toroid.
Yeah. Each of those three tricuspid valves creates its own individual toroidal vortex. But because the blood flows in a continuous cycle right side, to the lungs, to the left side, out to the body, these three vortexes interact and physically overlap.
Amplified by that spiraling myocardial muscle band we talked about, they merge into one massive complex electromagnetic field.
And the HeartMath Institute has actually conducted extensive research on heart-brain coherence. They found that this toroidal shape allows the heart to generate the strongest electromagnetic field in the entire human body.
We should probably quantify that because strongest can sound a bit abstract.
Fair enough.
The field is measured using magnetocardiography, or MCG, in units called picoteslas.
Picoteslas.
Yeah. To give you a sense of scale, a strong fridge magnet is measured in standard teslas. A picotesla is 1/1,000,000th of a Tesla.
Which sounds infinitesimally small.
It does, but for a biological electrical signal, it is massive. The electrical field of the heart is about 60 times greater in amplitude than the electrical activity generated by the brain.
60 times! That's incredible!
And its magnetic field is approximately 100 times stronger than the brain's.
Because it forms a toroid that's self-sustaining donut shape, that magnetic field extends several meters outward from the physical boundary of your skin.
HeartMath's data actually shows this field directly influences our cognitive intuition and our emotions.
It doesn't just stay inside us.
Right. It can even synchronize with the electromagnetic fields of other people around us.
Yeah.
Think about a mother holding her child. Their heart rate variability or HRV rhythms will actually entrain to one another.
The stronger field essentially pulls the other into coherence.
Exactly.
Yeah.
But, wait, hold on. I need to push back on the physical mechanics of this for a second.
Okay, lay it on me.
I understand that moving blood creates a magnetic field. But why does a three-part system arranged at 120 degrees create a more stable or powerful field than a simple two-part system pushing back and forth?
That's a great question.
Like if I have three separate forces pushing toward the center of a triangle, Shouldn't they just collide and cancel each other out? Kind of like a three-way car crash?
You would think so, but that is where the concept of phase timing comes in.
Phase timing.
Yeah. Think about how we transmit massive amounts of power across a city. Electrical engineers use a three-phase electrical power grid. In a binary two-part system, you create a linear dipole wave. It pushes, it pulls, it's a straight line, and there is a tiny moment of zero power when the wave reverses direction.
Right, there's a gap in the momentum, like hitting the end of a swing set before you come back down.
Exactly. But when you introduce a third element and space them all at exactly 120 degrees, you create spatial symmetry. Because of the timing of the wave, as one phase is peaking and pushing forward, the other two are at different stages of pulling back.
So they never collide.
They never collide. Instead, they seamlessly hand the energy off to one another.
Oh, wow. So instead of a tug of war where momentum stops and starts, it acts like a perfectly balanced wheel that never stops rolling.
You nailed it. The 120-degree system creates a stable, three-dimensional structure that continually recycles energy. In the center of that equilateral triangle, there is no destructive interference.
The energy just sustains itself through rotational symmetry.
Right. And to really grasp the implications of this 120-degree biological engine, the sources suggest we have to step completely outside of standard anatomy.
Step outside anatomy.
Yeah, we have to look at the physics of acoustics and resonance through the Triaural principle.
Oh, right, the AI interview. The document brings in this highly conceptual thought experiment involving an AI exploring the physics of a three-pronged tuning fork.
It's a brilliant way to visualize it. If you picture a standard tuning fork, it has two metal prongs. When you strike it, those two prongs vibrate back and forth toward each other.
Which creates a linear sound wave, a dipole. It is a simple wave of compression and rarefaction, pushing air out, pulling air in.
Exactly. But imagine a tuning fork made of the exact same material, but constructed with three prongs, arranged in a circle at 120 degrees.
Striking that triaural tuning fork produces an entirely different interference pattern, doesn't it?
It does. Because of that phase timing we just discussed, you aren't just pushing air back and forth. You are creating a complex tripolar acoustic field that radiates outward as a continuous toroidal wave.
It doesn't just buzz. It breathes in three dimensions.
Breathes in three dimensions. I love that.
And applying that back to the chest cavity, the three tricuspid valves act exactly like the three prongs of this theoretical tuning fork.
Yes, they are three radiators vibrating together in the dense fluid of your blood, creating a master resonant field.
And that two-cusp mitral valve we mentioned earlier, that acts as the solid base or, the handle of the tuning fork, keeping the whole acoustic structure grounded.
Which reveals that the 120-degree geometry isn't just an anatomical quirk. It is the universe's preferred geometric shape for stability and resonance.
You see it everywhere. You see it in the molecular resonance of benzene rings in organic chemistry.
You see it in the hexagonal structure of ice crystals.
Snowflakes, yeah. And you see it in the toroidal spin of galaxies. The human heart is literally utilizing fundamental cosmic geometry.
It is wild. And the sources actually outline a mental experiment to demonstrate what this means in biological practice.
The 528 hertz experiment.
Right. Imagine a triaural field, our three-pronged tuning fork tuned specifically to 528 hertz.
Which is a frequency often associated in alternative acoustics with biological repair and profound relaxation.
Exactly. If you focus the acoustic pressure of that specific 120-degree field onto a single point, say a human body, or even just a glass of water, it creates what the text calls a hot spot of transformation.
A hot spot of transformation. Because the waves are mathematically prevented from canceling each other out in the center, they amplify. They create standing waves.
Yes. And in a fluid medium like blood, this induces a phenomenon called acoustic streaming.
Acoustic streaming.
The concentrated sound waves physically align the molecular dipoles of water, generating actual microcurrents within the fluid.
Oh, wow. You know those science demonstrations where someone puts fine sand on a metal plate, runs a violin bow along the edge, and the sound waves cause the sand to suddenly bounce into these intricate, perfect geometric snowflake patterns?
Cymatics, yes.
Cymatics.
Right.
Now, imagine doing that, but instead of sand on a flat 2D plate, it is happening inside the blood and lymph fluid of your own body in three dimensions, generated continuously by the geometric pulsing of your own heart valves.
It's a constant vibrational tuning of your internal fluids.
But that raises a massive conceptual hurdle for me.
How so?
If the heart is a triaural resonator, generating 3D cymatic patterns in the blood and projecting a massive electromagnetic toroid around the body. What exactly is it resonating with? Or broadcasting, I guess.
The physics modeled in the sources points towards something remarkable. A coherent geometric field acts as a carrier wave.
A carrier wave, like radio.
Just like radio, like an FM radio station uses a coherent electromagnetic wave to carry complex audio information to the antenna on your car. A stable triaural field can carry biological information.
So it would function as a bioresonant communication system that entirely bypasses traditional chemical pathways. Wait, are we saying the heart could literally be carrying and broadcasting information? That it could be tuning our cells through these geometric vibrations, rather than just acting as a cargo ship delivering oxygen?
If the field is stable enough, yes. The mechanics support it entirely. If your heart is in a state of coherence, perhaps achieved through focused intention, deep breathing, or meditation, those 120-degree valves and that spiral muscle are mechanically translating that coherence into a toroidal wave.
A wave that physically washes over every single cell in your body.
And potentially radiating out into the environment around you.
Which is just staggering to think about. It definitely makes you rethink everything about that thumping sensation in your chest.
It really does. It's not just a pump.
Not at all. We have covered incredible ground today. We started with the physical architecture, 3 tricuspid valves, perfectly arranged at 120 degrees, firmly anchored by the mitral valve, pushing blood in a twisting, spiraling vortex through a figure-8 muscle.
We then followed that twisting conductive fluid to its natural energetic output, the master toroid, the strongest electromagnetic field in the human body, made possible by the exact same physics that stabilize a 3-phase electrical grid.
And finally, we view the human body through the lens of acoustics, seeing it as a living, breathing triaural tuning fork, an intricate geometric resonator capable of carrying information, inducing acoustic streaming in our cellular fluids, and maintaining coherence throughout our entire biological system.
It is a totally different way to view human biology.
It is. Some researchers and traditions suggest that the heart is something infinitely more than just a pump. They propose it as a profound network for information, maybe even a center of consciousness.
Right.
Now, we don't have definitive mainstream clinical data to fully map out human consciousness just yet, but the geometry of the organ really speaks for itself. We will leave it to you to weigh the data and form your own opinion.
I think that's the best approach. Because if geometry is a guide to understanding reality, then the heart, with its 3 valves at 120 degrees, its spiral muscle, and its toroidal field is not just an organ. It is a perfectly tuned resonator, exactly what the Triaural project explores as a principle.
Definitely something to mull over the next time you feel your pulse. We want to warmly thank you for joining us on this deep dive.